Hi everyone, in this video we will understand what is IoC container in depth. Okay, so the agenda of this video is, first we understand the concept of inversion of control. So what is inversion of control? Okay, why it is named so, we will understand, and then we will understand what is IoC container. Okay, that is what is inversion of control container, what it will do and what are its responsibilities. Okay, so this is very important to understand before jumping into the Spring concepts. If you understand this, then it is easier to understand Spring concepts very clearly. Okay, and also nowadays definitely you can expect one interview question on what is inversion of control or what is IoC container. Come on. Okay, so if you see this diagram, okay, this is a traditional approach. Okay, so where if you see this, actually in the main method I am creating an object for user service, right, using new operator like this. So if you see this user service class, it has a constructor, and inside the constructor I have a dependency called user DAO. That dependency, for that dependency I am creating the object. So who is creating the object? User service itself creating the object. So it is controlling the object creation, right? Similarly, while I am trying to create user DAO, again user DAO has some dependency on data source object. So that's why again user DAO, it is creating its own dependency like this inside the constructor. So if you see the control, starting from user service creation, first the control is trying to start creating the object, user service object. Inside it is creating user DAO. Again inside user DAO it is creating data source. So this is how the control is flowing from top to bottom, right? So this approach we already saw in the dependency injection video, right? What are the problems it will face, and we resolved it using dependency injection technique, right? Yes. So in IoC approach, what we will do? So in IoC approach, we create like this. Data source first I create, because data source is needed for user DAO. Then I create user DAO because user DAO is needed for user service. Okay, so how we have to change this classes structure now, we will see. See, user service structure I have to change like this, because it has to take the dependency as an argument. That means it has to give up the control of creating the object to some external entity, right? Here the main method is the external entity, we can say, or the class which is containing this main method is the external entity. Okay, so this is how we discussed in the dependency injection video, right? This is how we have to write, we have to change the design pattern here, right? Similarly, user DAO also, it is depending on the data source object. So data source it should not create in dependency injection, right, pattern, right? So what it has to do, it has to take the dependency as an argument through the constructor or the setter method or a field injection also possible. So here we are discussing constructor as an example. Okay, so this is how we need to write the structure. So if we write like this, you know, right, what are all the advantages we get? That advantages we already discussed in dependency injection. So please, if you have not gone through the dependency injection video, I have provided the link in the video description. Please go through that video. Okay, and if you see this pattern and traditional approach and IoC approach, if you see in the IoC approach, why we are calling it as inversion of control, we will try to understand. So if you see this, the order in which it is following, if you observe in this approach, it started, the control is coming to user service first, then user DAO, then data source, right? It is when we in the inversion of control, when we say control, it is the control of objects creation. Okay, if you see the control of objects creation, the order how it is following in the traditional approach, first user service, then user DAO, then data source. But in the inversion of control, it is reversed. Do you observe it? It is reversed. First it starts with data source, then user DAO, then user service. So if you see this order, start data source at the last, right? But here data source at first. Here user DAO second, here also second. User service start creating the user service object first, but here it is creating at the last. If you observe this, this is inversed, right? So the control of object creation is inversed, that means reversed completely. So that's why we call it as inversion of control. So inversion of control, it is being possible. It is possible with the dependency injection only, right? That's why in the dependency injection we discussed, we use dependency injection to achieve the inversion of control, right? Here we are achieving this inversion of control approach using dependency injection, right? So here in the main method, if you observe, we are creating data source object which is a dependency for user DAO, and after creating this data source, I am injecting this data source into user DAO object through the constructor. So this is a constructor injection, right? Again, after creating user DAO, this is dependency for user service, right? So I am injecting this user DAO object into the user service through the constructor, right? So again, these two steps, if you observe, dependency injections are happening through the constructors, right? So using dependency injection, we achieve inversion of control. What do you mean by inversion of control? In the inversion of control, we put the logic of object creation outside the application logic into a common place. So what is taking care of creating the objects and maintaining the dependency injection? The external entity. If you take this main method, if we take this class containing the main method, we can call it as an external entity which is taking care, which is managing the life cycle of the beans in the sense here the objects, we can say it is maintaining the life cycle of the objects, and it is a one entity which is taking care of everything. So now with this we have advantages, right? The advantages we discussed in dependency injection, right? So this is called inversion of control approach. In inversion of control, we take out the control of object creation from the classes to some external entity. So with this we achieve loose coupling, testing it will become reusable. So many things we discussed, right? Yes. So this is how we need to understand. IoC means inversion of control. Why it is named so? Now do you understand, right? Because the control is reversed. The control of object creation is reversed completely, right? Here the control, it is coming from user service to data source, but in the inversion of control it is reversed, right? It is coming from the data source to user service, right? First it creates its dependency, then it will create the actual class, right? So this is what we need to understand. This is called IoC approach. Okay, so this logic, if you observe this logic, right? This logic normally in the IoC containers, that means normally in the IoC frameworks like Spring, this logic is performed by a particular class or a particular entity. Okay, we call it as, so that we can call it as IoC container. So creating the objects, injecting the dependencies, and maintaining everything, the life cycle of the beans from creating to destruction of the objects will be taken care by some container. We call it as a container. The container which is performing the inversion of control, right? That's why we call it as inversion of control container. I think you got it now. Why we are calling it as IoC container? Because it is doing the IoC inside it, right? In IoC means it is completely doing the inversion of control. That is, it is first creating the dependencies and injecting them wherever required, and it has to follow the order also, because in order to create user DAO, first it has to create data source. So much logic it has to perform. It is the responsibility of IoC container, right? You got it, right? This is the concept of IoC container. Now just we will go through some points. So what is meant by IoC? Normally IoC stands for inversion of control. Basically it's a design principle where the control flow of a program is inverted compared to traditional programming approaches, right? That's what we understood, right? Instead of the developer directly controlling the flow of execution, control is delegated to an external entity or container. This is what we understood, right, in the previous slide. In practical terms, IoC often involves dependency injection. Without dependency injection, we can't imagine IoC, right? IoC needs dependency injection, right, where components dependencies are provided by external entity rather than being created or managed directly by the component itself. This is what we understood, right? Yes. This inversion allows for more modular, flexible and testable code has components become loosely coupled and easier to replace or modify. This is what we understood already in depth. We discussed in dependency injection video. Please, I suggest you to go through that video to understand this video more clearly. Specifically to understand the benefits, please go through the dependency injection video. And IoC commonly used in frameworks, right, like Spring for Java or Angular for TypeScript. Okay, so this is IoC is a core part. If you understand IoC, then you can understand the responsibility of Spring framework also very easily. Okay, now we understand what is IoC container. What is IoC container? Definition. It's a normal definition. We can say it is a container. It's a software component responsible for managing the instantiation, that means creating the object, and life cycle of objects means from creating, initializing, and from to destruction. All life cycle methods, all the life cycle it will maintain. Okay, normally in frameworks like IoC frameworks or Spring or any frameworks, we call these objects as components or beans. Okay, and also this container is a key concept in IoC framework. When we start learning Spring framework, we have to start with IoC framework. Okay, this is a core part. This is a key concept. It is the heart of the Spring framework, we can say. Okay, so IoC is very, very important concept. And what are the responsibilities of IoC container? Responsibilities is very, very important to understand. If you want to design your own IoC container in future, who knows, you may get a chance. You may become architect. You may be placed in a product based company where you may need to design a new IoC. Who knows? So you have to keep these points in your mind. What are the responsibilities it has to provide? It has to do dependency injection. In the previous slide we discussed, right? It has to do the dependency injection. It has to create the object, and also it has to do object lifecycle management. That means it has to create the object, and also it has to destroy the objects. It has to initialize the objects, right? It has to do these many things. And configuration management, we have to provide some configuration to the IoC container so that it will read the configuration and it will create the objects accordingly. We have to tell to the container, right, hey, create this object, then inject that dependency into this object. I need this dependency to be injected into this object. So many things we have to tell to the container. So that configuration management, who will do? IoC should do. Okay, it has to provide a way for the developers to provide the configuration also. So configuration management is important. Then aspect oriented programming support. So any IoC container generally supports aspect oriented programming. What is aspect oriented programming for a beginners? You might not be knowing, but definitely this one we will be discussing in future. Okay, and error handling also. Normally in dependency injection, because it is IoC is taking the control of objects creation and maintaining the everything, right? So that's why error handling also becomes its responsibility. Okay, that error handling concepts, how it is dealing, we will definitely discuss in the future videos. Integration. This integration also is very important. When we say integration, IoC should be integrated with any other IoC framework. For example, let's say Spring I am using. Spring framework is an IoC framework, right? It should be capable enough to integrate with other IoC. Let's say JSF is there, Java Server Faces. In some Spring MVC applications, we use JSF along with the Spring framework. In that Spring, we call it as backing beans in JSF. That backing bean need a dependency which is Spring bean, which is Spring one. So in the JSF, in this backing bean, this IoC, Spring IoC should be integrated with the JSF IoC, so that JSF bean can be injected into the Spring bean. Spring bean can be injected into the JSF bean, so that the integration support also IoC should provide. So Spring is providing that integration support. Okay, if you want to design your own IoC, then you have to keep integration also in your mind. Okay, testing support. So Spring components testing support also it has to provide. That the way we test in Spring, it will become very easy because of the IoC. Performance optimization. It is very, very important. The order in which the dependency should be created, and while creating the dependencies, it has to keep the performance also in mind, and it has to optimize the performance. Okay, and documentation and tooling. So documentation also it has to provide, because without the documentation, how a developer can configure the objects, so that it has to tell to the container, right, create this object first, then it has to please inject that dependency into this object, some kind of configuration we have to provide, right? The documentation we need, right? How an IoC containers understand the configuration. IoC has to provide the documentation, so it has to provide, Spring is providing the documentation. And tooling, so tools is nothing but the way we define the configurations, the tools like annotations or XML way of doing it. Some in documentation it will mention this is how you have to use. The tools also it has to provide. In Spring it provides different annotations. In XML tags also it will provide those are called as tools here. So these are all the things are nothing but responsibilities of IoC container. IoC container has to provide all these things. Whenever you design your own IoC container, you have to make sure these are the things you have to provide. So these are the primary responsibilities of IoC container. Now I hope you understood IoC container, right? Congratulations. So IoC container, before jumping into Spring framework, definitely we have to understand IoC container, right? Now in the next video, we are going to discuss what are the IoC containers Spring has provided, and definitely that IoC container should do all these things, right? We will be seeing practically how it is providing all these things step by step. Okay, all the best. Thank you for watching the video. Please subscribe. Bye bye.